Now children, let us see some applications of Euclid's division algorithm. The first application, finding the HCF of two numbers by Euclid's division algorithm. Now the old method which we have been doing in the junior classes to find the HCF of two numbers, division method. In that we take two numbers, the bigger number we write inside, the smaller number we write outside, and we start the division process. Now here 225 is the dividend, 135 is the divisor, 1 is the quotient, and 90 is the remainder. Now in the next step we write 135, which was the divisor, as the dividend, and then carry on the same process. 135 is the dividend, 90 is the divisor, 1 is the quotient, 45 is the remainder. Again 90 is brought inside. The 90, which was the divisor earlier, now has become the dividend, and 45 goes twice in 90. So in the earlier classes, the last divisor was declared as the HCF. Now we shall use this as the rough work and find the HCF. We will be finding the HCF by using Euclid's division algorithm. Now what is Euclid's division algorithm? Let us say again, A is equal to BQ plus R. So we will write this division process in this form: A is equal to BQ plus R. A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. So we write 225 as 135 into 1 plus the remainder 90. In the next step again we start 135 is equal to 90 multiplied by 1 plus the remainder. The third step again we start here as 90 is equal to 45 multiplied by 2, remainder is 0. So we do this process, we continue this process till the remainder is 0. The last divisor is called the HCF. So here in this question, finding the HCF of these two numbers by EDA, HCF we have got as 45. Now let us apply this again. We shall again find the HCF of two numbers with the same method, 867 and 255. It is clear 867 is bigger, 255 is smaller number. We write the bigger number inside, the smaller number outside, and then carry on the division process. First we get quotient is 3, remainder is 102. 255 is brought inside, again quotient is 2, remainder is 51. Again 102 is brought inside, quotient is 2, remainder is 0. So the division process has come to an end. Now we shall write this process again using Euclid's division algorithm. A is equal to BQ plus R. 867 can be written as 255 multiplied by 3 plus 102. The second step, 255 will be written as 102 multiplied by 2 plus remainder 51. Then the third time, 102 divided by 51 gives you 2 as the quotient and the remainder is 0. Now when the remainder is 0, we shall declare the last divisor as the HCF. So now children, we have done two questions with this EDA, finding the HCF by EDA. And now to remind you children that this topic, finding the HCF of two numbers, is extremely important from CBSE point of view. Generally, one question finding the HCF by EDA is asked in the exam for around 2 marks. Another type of question, show that any positive odd integers, another application of EDA, show that any positive odd integer is of the type 6q plus 1, 6q plus 3 or 6q plus 5. Now this type of question, again this is asked for 2 marks in CBSE, where an easy question is to be set, this type of questions are asked. Now let us see how to do this question. We are told that A is any positive odd integer and we have to show that it is of the type 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5, and this is an application of EDA, Euclid's division algorithm. To begin with, let us start. Let a be any positive integer. Then by Euclid's division algorithm, a is equal to b cube plus r, where b is 6. We have to suppose this. According to the question, we have supposed b to be 6, and the remainder is very obvious that the remainder has to be less than 6. So the remainders are 0, 1, 2, 3, 4 and 5. We select those whole numbers which are less than 6 as the remainders. And now we shall start with all the remainders. First a is equal to 6 cube plus r, the Euclid's division algorithm, using b as 6. Now when remainder is 0, this expression is expressed as a is equal to 6 cube. When remainder is 1, in place of r we write 1. When remainder is 2, it becomes a is equal to 6 cube plus 2. We carry on this process till the remainder we have reached is 5. Now let us see. In the question we were asked that a is a positive odd integer. Now to find odd and even numbers, an expression from which 2 can be taken out common, that is an even expression. From this expression 6 cube, 2 can be taken out common, so it is even. In the second expression, 2 cannot be taken out common, therefore it is odd. In the next expression, again 2 can be taken out common from 6 cube plus 2, therefore it is even. Here 2 cannot be taken out common, therefore it is odd. Then the next, here again 2 can be taken out common, so it is even, and in the last expression 2 cannot be taken out common, therefore it is odd. Now let us look for how many of them were odd. 6 cube plus 1 was odd, 6 cube plus 3 was odd, and 6 cube plus 5 was odd. The question was, we were to show that positive integers are of the type 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5. Hence we have arrived at the answer that every positive odd integer is of the form 6 cube plus 1, 6 cube plus 3 or 6 cube plus 5.